Hey everyone, I'm here to talk today about the Markforged Metal-X process. It's a simple, safe, and cost-effective method to go from design to functional metal part. There are 3 steps in this process: printing, washing, and then sintering. First, let's start with CAD. You design your part, then export to STL and upload into Eiger. Eiger is a cloud-based slicing and print management system that comes with every Markforged product. This automatically configures your part based on the material and printer you've selected. When your part slices for metal 3D printing, it gets scaled up to account for shrink and deformation in the downstream processes. It then slices your part into discrete layers, identifies overhang features, and builds supports and a raft underneath your part. As we go through printing, washing, and sintering, Eiger will monitor the part's progress along the way. Let's start this print and go to the Metal-X. Before starting a print, the machine automatically maps and levels the bed to ensure the first layer goes down well. Your print is built of 2 materials stored in this heated chamber above. One of ceramic release material and one of the metal to be printed. This filament material is metal powder safely suspended within a 2-part plastic binder. It gets heated and extruded onto the build plate where the part is created layer by layer. The release material gets extruded as an interface between the part and its supports, so that once your part comes out of the furnace, it's easy to remove. Unlike other metal 3D printing systems, this process does not require loose metal powder, resulting in a safer and more cost-efficient workflow. 17-4 stainless steel is loaded now. However, with a quick changeover, the system is capable of printing in stainless steels, tool steels, coppers, Inconel, along with several other materials currently in development. Once your part is finished printing, you'll get a notification. At this point, you can go to the printer, remove the part from the build tray, and clear the bed. Now we have what's called a green part. It doesn't really look or feel like metal. However, a large part of it is comprised of metal powder. Next step will be putting it into Wash 1 for the debind process. The Wash 1 removes the first stage of the binding material. A green part is taken from the printer and placed into the wash basket, which is then lowered into the solvent. Wash times will vary, ranging from a few hours to a few days, depending on the thickest region of your part. After that, it's now called a brown part and is ready for sintering. Let's go over to the furnaces. This is Sinter 2, a furnace designed for mid-volume production runs and larger printed parts. Sintering transforms a print from a lightly bound collection of metal powder to a fully finished metal part. First, the temperature ramps slowly to burn away the trace amounts of remaining binding material. Then, temperature ramps closer to the melting point of the material, allowing metal particles to start to fuse together to create a strong metal part. Markforged sintering furnaces use a carbon-free retort to ensure part quality and alloy composition standards are met for our finished pieces. Each run takes about a day and can be monitored remotely using the Eiger software. Once a run is complete, the setter tray full of finished metal pieces can be removed from the furnace. Once removed from the raft, these parts are ready for use. In the furnace, the layer of printed release material between supports and the raft and your printed part remains powderized. This allows the structure to be tacked to the raft to better control shrink and accuracy throughout the process, but also an easy release after sintering. At this stage, your part is fully sintered and ready to be used. It can be post-machined, polished, or otherwise processed as necessary for the final application, but in many uses, the accuracy and strength are good enough as is. It's ready for install. Check out markforged.com for more information about our simple, safe, and cost-effective method of metal additive manufacturing.